So the first function, y equals 1 over x squared plus 4x. Look at the denominator and pretend you're sketching that. So we'll call that y1 is x squared plus 4x. Just the denominator. You should be able to draw that very quickly. Okay? It's a parabola. It's positive. It has x-intercepts. If you factorised, it has an x-intercept at 0 and a negative 4. Okay? So it's a parabola that looks like this. So you quickly sketch that. We might as well find the turning point too, because that will become relevant for us. So the turning point is negative 2 and negative 4. So this is y equals x squared plus 4x. Directly below, let's draw 1 over. This was negative 4, directly below it. X equals negative 4. Asymptote. Wherever you have an x-intercept, when you flip it, 1 over 0, undefined. At 0, we have another asymptote. Behaviour of the function. This is a tiny y value. It becomes a large y value. As you move on, the y values become larger. When I take the reciprocal, they become smaller. So we will get a function looking like this. That wing there becomes reciprocal. This side is exactly the same. Small, big, big, small. Minimums turn upside down, becomes maximum. The x value never changes. Your y value was negative 4. This y value becomes negative 1/4. And instead of getting less and less negative, we're going to get more and more negative. That's it. Turning point, turn upside down, relabel, and the two wings flip out. That's it. So every time you see a function like this, it's going to look like that. If they decided to make life more difficult, they could turn around and do something like, let's say that's 3 over. Okay? I wouldn't worry about the 3 till after you flipped it. And then what the 3 does is dilate it, so you might make it look, and then times this by 3, so the negative 1/4 becomes negative 3/4, and so it opens up down here. If they decide to be nasty, put +1 on top of it. Move the whole graph up by 1. So it doesn't matter how bad it becomes, focus on the denominator, draw it, flip it, and then go for it.
So what's the term
That's negative 2 and negative 1/4.
So you say so the x.
Oh, but the x value never changes. Yes. And if it was times 3, it would be negative 2 and negative 3/4. So the x value does not change. Only the y value by dilations.
So what? So you flip the y value.
Yeah.
You reciprocal.
The reciprocal of the y values, exactly right. So if we looked at this, we should be able to knock this off in like 2 seconds. Original function, 4x squared minus 9, y-intercept. Faster. Negative 9. Parabola looks like this. X-intercepts. Good. Negative 3 on 2, 3 on 2. Directly below. asymptotes. X equals negative 3 on 2, x equals 3 on 2. Right? Negative 9, negative 1/9. Wing, 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 wing. Every time. And if I stuck a negative in front of it, the whole thing would be upside down. If I had a negative x squared function, imagine turning that upside down. That's all that's going to happen. So that's parabolas by reciprocals. It's pretty easy. Yeah. Simple. One more before we go to the back. Draw x squared plus 5. You all knew that, didn't you? It's not just scar, but it's a positive parabola going through 5. So, what's my asymptotes? Okay. Now, there's a thing I haven't mentioned here too. What are my asymptotes here? If I was asked to state my asymptotes for this, what are they? Yeah, what are the asymptotes for this function?
X equals 3 or 3 minus 3.
And y equals 0. No.
Sorry, someone said something. Speak up, don't be shy.
Y equals 0.
Y equals 0, well done. Right? Y equals 0, y equals 0. So we don't show it, but y equals 0 is also an asymptote because that function will not hit that line. So it's very important. Right, that's like in methods, if you've got a hyperbola and you've got nothing written next to it, you've got y equals 0 as another asymptote. So, for this one, the only thing I know is that there will be an asymptote here. Yeah? Because it doesn't matter how large x becomes, you can't get y being 0 or whatever. Right? What about the 5? The 5, so really have done stuff up the scale, that'll be negative, that'll be 1/5, sorry. Because you take the reciprocal of 5, it'll become 1/5. If that was a minimum, I have to become a maximum. And then I just draw a little bump. Bump. There's your function. It's a little volcano looking thing. And it approaches 0 as an asymptote. Right? So if you can't factorise the denominator, that means there are no x-intercepts. If there are no x-intercepts, that means there'll be no vertical asymptotes. There'll still be a horizontal one always, but there won't be a vertical one. And then you just get the little bump. Right, kill it.